Hi everyone. My name's Joe Heelan. I'm one of the co-founders of Powders on Demand. So obviously, thank you all for joining the CSAT webinar series as we lead into the conference. I think we're about 2 weeks out now, 2 weeks as of this Tuesday. So it's coming down the pipeline here. If you haven't registered yet, Nicole, I think you're going to provide some details for registration. So take a look at that if you want to go ahead and get signed up here. Today, we're obviously really excited to talk about and welcome team members from Centerline, who's been one of CSAT's sponsors for really a long time now, and one of the major contributors to both advancement and commercialization of the cold spray technology as a whole over the past few decades now at this point. And most recently, they've been focusing on automated repair and more production ready industrial size pieces of equipment. So joining us today, we've got Bruce Coulter and Wally Birch from the Centerline team. Bruce has spent really the past couple decades or more than 2 decades leading business development efforts in advanced and probably predominantly additive manufacturing, specifically focusing on laser powder bed to start, transitioning into DED, and then more recently, so probably over the past 10 years or so, working specifically on cold spray. And I've probably known Bruce during a good chunk of those 10 years. So Bruce is the third generation in manufacturing engineer, and he's really built a career around identifying and then also commercializing emerging manufacturing technologies across multiple different industries. Also joining us is Wally Birch from the Centerline team, who's got more than 23 years at Centerline, supporting engineering, application development, and then technical sales as well. Over the course of his career, Wally has played a pretty hands-on role in implementing and optimizing cold spray systems across multiple different industries. Essentially, you name the industry, he's probably been working in it. And his experience spans both technical and then also the operational side of cold spray deployment. So these guys they're going to be presenting on smart repair for cold spray. So Centerline has developed what is believed to be the industry's first fully automated cold spray repair platform that utilizes AI-based scanning, automated tool path planning, and then also robotic cold spray deposition for repair and coating applications. And I'll kind of let them speak to the specific capabilities. We're going to encourage questions throughout the session, so please go ahead and there's a Zoom Q&A feature at the bottom of your screen to actually submit questions that we can go through. And then also want to highlight that today's webinar is being recorded, and we're going to make that recording available publicly after. So you don't need to worry about taking notes or jotting everything down. We're going to share that with you after the presentation's done. So with that, I'll turn that over to Bruce and Wally, and Bruce, the floor is yours to get started here.
Fantastic. Thanks so much, Joe. Thank you to CSAT Solvus Global for the opportunity to address this distinguished audience on Centerline's SST's award-winning cold spray technologies. Plus, Wally will tell you about our new releases, as Joe just highlighted. I'll speak to the Centerline company and current technologies, capabilities, and benefits, while Wally will tell you about the new groundbreaking product offerings, our ultra-portable PX suitcase system, the aforementioned smart repair cold spray system, and the ability to get any of our cold spray systems in a Connex box or trailer to get repair, coating, feature additions to the point of need. So let's begin. First, for those of you who aren't familiar with Centerline, we're a privately owned $200 million plus company based in Windsor, Ontario, across the river from downtown Detroit. Centerline has 1,100 employees worldwide, is voted every year as one of Canada's best managed companies. We perform world-class manufacturing and welding, metal forming, robotic, and cold spray solutions serving aviation, aerospace and defense, energy, oil and gas, automotive, heavy equipment, glass, consumer packaged goods, and tooling applications. Centerline has facilities in 10 locations. 3 of those are in the United States, 10 around the world, for supporting over 150 of our cold spray installations. Specifically, these are some of the Centerline SST customers in an array of different markets and applications. Centerline SST's core product line consists of our PX low-pressure cold spray systems and our EPX medium to medium high pressure systems. And of course, we are the world's leader in integrating our cold spray solutions with walk-in spray booths, robotic cold spray systems, and more. Given Centerline's background in large robotic production systems overall, we ship $1 million systems every year and recently shipped a $3 million cold spray production system. Cold spray has been around for 30 or 40 years, but Centerline SST has perfected 2 key components of the process: the spray gun, and specifically our downstream injection nozzle technology, and our unique gas and powder delivery system. Our powder feeder is the best technology on the market today. These unique capabilities provide quick heat up time so you can get to work quickly and dramatically reduces clogging. The basic SST product line consists of our PX cold spray system in a manual or robotic configuration and our EPX system in a robotic configuration. As you can see on this slide, SST can provide integrated solutions for all kinds of applications in different configurations: walk-in spray booths, robotics, etc. And SST provides innovative and high-quality consumables and accessories like the smallest ID bore spray gun under 2 inches, modular nozzle systems, calibration kits, and our best-in-class powder feeders. Now I'll turn it over to Wally Birch to tell you about Centerline SST's new developments. Come see us at CSAT or connect with us via our emails, bruce.coulter@centerline.com, wally.birch@centerline.com. Wally, take it away.
Thanks, Bruce. Next slide. So back in 2007, we did do a suitcase version of this. Had some customers looking at this for repairing IBD aluminum repairs on landing gear. So it would be a repair on wing. But the project never went to fruition because it ran out of money for doing fatigue testing. So we basically dropped the project at that point because there was no further interest in at this point. So we continued on with just our standard PX. Next slide. So we've had some rejuvenation on that front, and we're re-engineering this product again. As you can see on the left side, we've got our control cabinet in a Pelican case, and then we've got the green portion there is an auger feeder that would be flipped up and put into position and would be the feeding portion of the powder to the gun. The second case on the right side houses the gun, some powder, tools, consumables, nozzles. So that's basically what we're going to end up with is 2 small Pelican cases that would allow it to be very mobile. Our targets are weight would be less than 60 pounds is our target for both those. So still very movable. Next slide. So the next few slides we've put together is about our smart repair system, which is in conjunction with Cirrus in Australia, cover continuous 3D software. Next slide. So this slide is showing, well, back up one, we can get the video going. Okay, so what we're doing here is we're scanning the part. It's set up that we've used two robots in this place because we had two robots available and we didn't have a turntable available. So we used one robot to simulate a turntable using only two axes of it. So what we're doing here is scanning the part every 20 degrees. We're rotating the part and scanning over that system again. So it'll rotate around here for the full part, producing a point cloud, which we transfer into a CAD model from that standpoint. And once we've got that totally scanned, which generally that takes about 20 minutes to scan this part. In reality, we've speeded this up quite a bit for just a video short time. So when we're complete here, we will be able to select certain areas, or we could compare this to a CAD model if there was one available to see if there's any differences between the CAD model and the part. But generally, we know what areas are need to be repaired, so we will probably go directly to that. We'll just let this run out till it's finished, and we'll compress to the next slide. So we've got a completed model now. There are some holes in it. I mean, we could go back and do some different angles to get more features, but generally the flanges that we were interested in are already scanned in and look very good. So we're not going to spend much time going back and replacing all those vacant holes. Next slide. So in this slide, we've actually taken the point cloud and put it into CAD, and now we've already generated a toolpath, and it's going in to spray that area that needs to be repaired. So in this case, we were spraying aluminum oxide mixture onto a magnesium casting. So this particular product took about 2.5 minutes to spray, and we used 33 grams of powder to spray up that flange, and then it'll be ready for remachining and bringing it back to spec. Bruce, can you click on the center? Yeah, okay, it
Yep.
went automatic. Okay.
Yep.
This is just a close-up of this same spray, but we'll speed it up a little bit too. But this whole toolpath was generated automatically from the continuous 3D software. So there's no programming required by a robot programmer to do this toolpath. Next slide. So it is a little bit larger flange that we're looking at here. I mean, we would normally put a mask on there to instead of dragging the spray across the part. But in this case, we were doing experimental stuff and developing programs. So we didn't bother with any masks because this was a scrap part anyway, and we were just developing processes. So from the time we would start scanning to had this program written and we were spraying, took a total of about 2.5 hours, which is phenomenal compared to having to bring in that model, write a program, even offline, would take much longer manually than 2.5 hours. So you'd be looking at, probably a couple of days of programming to do that similar tool path. So in this case, this part took 7.5 minutes and we used 90 grams of material. And we were running at a traverse speed of about 25 millimeters per second. Again, we were using aluminum oxide composition for the powder. And so the next slide here, we were looking at repairing holes in aircraft panels that have got chamfers on them. And we had seen a number of panels that had oblong holes from the rivets had been moving, or the fastener had been moving to elongate the holes. So we were looking at developing a process to scan the part, figure out where the holes are in the panel, and then go back and write a program to fill those chamfers in to remachine them and get to the correct dimensions again. Next slide. So in the panels we were looking at, we were just taking some 5083 plate, and we just bored some holes and did some chamfers and had simulations, and we were going to use that as our test program for developing a program. Next slide. So when we analyzed that and we come up with a tool path, it was a 3-spiral path that was generated to fill in that chamfer and hole. Next slide. And that was the end result, where we did that 3-spiral with filling in that chamfer, and now it's ready for remachining and re-chamfering to locate the hole right back to dimensions. I thank you.
Okay, very good. Thanks, Bruce and Wally. Very exciting work. So we can take this time to open up the floor to some questions. And again, there's a feature at the bottom of your screen here. If you click on the Q&A feature, it might be hidden under the 3 dots more. You can ask questions there, and we can go through these live. I had a few of my questions of my own, and then there's also a couple questions here that were gathered in advance of the presentation that we can go through. So Wally, what stage is the smart technology in currently? Is it already commercialized at this point? Is it still in development? How far along are you with it, and are you actually using it for actual repairs to date?
We are not using it for actual repairs to date right now. We will have an installation in one of our customers' facilities by mid-June, and they're planning on using that to repair castings. I would say they would probably be up and running in the August timeframe is their objective. And then we will be installing a duplicate system in our lab which we'll be able to use for demos, which will be up and running in probably the October, November time frame. We're just putting a new robot in, a new turntable to accommodate that. So we will have a full set of softwares and capabilities inside Centerline to do demos and illustrate parts.
Okay, very good. So this is a potential add-on that you can get, buy as a package down the road, correct?
In certain cases, if the robot controller is new enough,
Yep.
they are adaptable as an add-on. We would have to look at the robot's arm capacity because we're adding that laser bracketry and laser to.
Sure.
So there'll be some caveats we'd have to look at as a retrofit.
Okay, great. Here's another one. How important is process monitoring and data collection to the smart software? Has that been implemented at all? Have you started to actually have in situ, control and process monitoring as part of the smart technology?
Not at this point. It's still open circuit.
Yep.
We are looking at powder feed rates and that being fed back into it from a weight loss on the powder feeders. That's about the extent of it at this point. Temperature wise and pressure wise, it's all external programmed. It's not tied in with the software.
Okay, got it. And then here's a question from prior to the presentation was submitted in advance. What untapped application do you see as the biggest use case for automated cold spray repair?
Oh, I think any aircraft component that
Aircraft.
has
Yeah,
got corrosion or dimensional restoration needed is definitely
sure.
a big candidate for that. I'm looking at industrial engines too. I think there's a good market there in rebuilding industrial engines and applications. So I think it's unlimited right now at this point. It's from what I've seen, the the automation of it is so simplified compared to doing programming manually that
Yep.
is going to be widely adapted.
Okay, great.
I mentioned one other one, tooling repairs. We've had some requests on that already, so that looks like
Yeah.
that's a nice application.
Yeah.
Okay.
Yep.
Um, and then, question just popped into my head as well. Have you- the raster pattern, right, with the nozzle,
Yeah.
by running the scan and developing your robotic control and the actual path plan associated with it, it's a little different than your conventional, back and forth, move that down the part. Have you seen any differences in performance by changing around the geometry or the shape of the part that you're doing? Or, I guess what performance metric have you been controlling off of? Is it mostly adhesion or are you looking at other properties as well?
Basically adhesion at this point, Joel. I mean, we haven't done extensive testing in different tool path uh, monitorings at this point, um, but primarily it is straight rastering, other than doing the circles.
Yep.
And we are doing some more development in torch angle as far as trying to square off edges and stuff like that, which are not 100% there yet. We're working on that. So, like for instance, that chamfered hole. I mean,
Mhm.
did some development on that to get a straight hole out of that, and that is required in some of the applications on just on the straight castings too. So yeah, we're not 100% there for sure, and there's still a long ways to go to develop everything that is got the capability of.
Okay, great. And then another question in here, a question in advance. Are you seeing the industry begin to standardize around common cold spray qualification approaches, such as the Navy Tech Pub and established repair frameworks, or has qualification still largely been mostly customer specific today? So question around qualification.
I'd say it's at this point it's still more customer related in what their needs are rather
Okay.
than a standard. I know there are some people working on some standards, but it really has been so far in my experience that it is up to the individual customer that what their requirements are, and they're putting specs together relative to their needs, not a universal need.
Sure. Okay. Yeah, I think we've seen something consistent, depending on what organization you're dealing with.
Yeah.
Okay, question from the group here. How about the bond strength? What's been the measured bond strength for the smart system? And
I haven't,
what specification are you using? Is it the bond button testing, the ASTM C633?
yeah, 633 is what we've been using so far with the adhesive material. We're seeing no difference in the bond strength between the tool paths we're generating with the smart repair versus a manual programming, robot programming tool path.
Okay.
I mean, we use the same step over methods. We have to program that into the smart repair. So if we're using a 1.5 millimeter step over, that's consistent
Hmm.
with what we're going to do in the smart repair also. So that
Okay.
doesn't change.
And it is the target glue failure or 5 KSI, or what's been your standard for that system?
It really depends on the material we're trying to spray and substrates, but yeah, the target is breaking glue.
Yeah. Okay, very good. Any other questions? We'll give a few seconds here, see if any more come in. And I'll check the chat quick.
And Joe, I know Nicole put up both of our contacts, so
Yep.
anybody thinks of something later on, they can reach out.
Okay, very good. So yeah, if you check the chat, there's Bruce and Wally's email address there. Of course, you guys will be at CSAT as well.
Yep.
And then just a quick reminder as well, this is going to be publicly distributed, so you can have access to the recorded presentation. But yeah, obviously very interesting stuff here, and thanks again for everyone attending the webinar. Be sure to look into attending both CSAT and LSAT. LSAT's directly after CSAT. That's going to be June 9th through June 11th. And we're all especially looking forward to Centerline's live expeditionary cold spray demonstration, which is going to be at CSAT on Wednesday at Worcester Polytechnic Institute. So that's a few minutes away from the DCU Center, and that's going to be on June 10th, the afternoon of June 10th. So
Yep.
thanks again, obviously, great presentation. Hope to see you all soon.
All right. Thank you.
Thank you all.
All right, take care now.
Bye now.
Yep.